Hi guys, and welcome to the next episode on the AI Upskilling Framework series. And welcome Jose, welcome Yimi. Thanks for joining. And it's great to have you here and discuss today the level 4 training and maintaining um, models. How are you guys?
I'm good. How about you, Jimmy?
Fantastic, fantastic.
That's great. Thank you very much. So first of all, we need to introduce, however, the AI upscaling framework. We have done 3 levels already on understanding, on applying, on building, and today we're talking about training and maintaining models. And this is the level for um, all staff engineers implementing AI and machine learning, and we will do some demos on Azure ML, but also discussing the possibilities how to train and how to maintain models. Um, First of all, if we're talking about GenAI in 2025, the Harvard Business Review have done some use case reviews what we are doing right now, and we see that today, this year, we are moving from 19 on improving code for professionals to 8 running, generating the code for pros from 37 to 5, but also do engaged learning. And if we are, however, doing the search, you see that is somehow going down, and we do more productive stuff with GenAI right now. If we talk about the last few sessions, we have done this one. That is just a Copilot. We moved there, grab a license, talk about prompt engineering. Then in another one, we do the Copilot Studio, doing this no-code, low-code platform, or introduce the low-code, no-code platform. Last level or last week, we talk about Azure AI Foundry and doing some developer stuff. And now we are somehow here on doing for the data scientists, working right on the models and doing the stuff there. And first of all, of introduction, here we need to discuss, okay, how have you done this earlier, perhaps 10 years ago? We have created something here like Azure Machine Learning Services. You can just grab them from Microsoft Azure, just create this kind of resource, and then you're ready to go and starting on building your own models with your notebooks, with your data, creating the models, publish the endpoints, and then use it. And the idea of this one is, of course, that Imi from Microsoft will talk in a few minutes more particular, okay, how to run this on Azure AI. And you will see the difference somehow from today, how fast is it going to be deployed and maintained and so on. So if you're talking about, if you're moving to Azure machine learning, and we're going right then to portal, and then to speak also with Jose about this one. So you need to
Mhm.
create this kind of resource. That is something like you just search for Azure machine learning and create this one. You see this is already here, will be provided by Microsoft. You can just create this one. We have done this not to waste some times from your directly, and you see here we get some studio link. If you click on this one, you will start on this studio. That was something from the screenshots we have done right now. But then if we want to start here, of course we have some models already here. You will see this is the same somehow from what I also see on Azure AI. If you want to run this on our own, for example, in a workshop, then somehow we create here something from template, perhaps also from samples, and then you see, okay, tutorials, something like Azure ML in a day. You see here notebook, and then you can clone this one and say, yes, I want to clone this. So it's all live, it's not recorded. So let's see if it's working. It's fast enough for us to run this or not. You will see the difference on Azure AI later. You can just create your model, and then it's there and you can just use it directly. What we need to do if we want to start on Azure Machine Learning, if of course to run some code. You will see here we need to import some dependencies, but I was not selected the compute. Sorry for this one. So
Alex,
we'll say,
me.
why do we need the compute there? What?
Easy. I would recommend that we give a holistic view of Azure Machine Learning because it's a lot more than just notebooks. So you have on the top, I'm not sure, I'm seeing that very small. You have a guide. I think it's on the second or the mid icon on the top right side on the blue bar, which
Yeah.
we can no go a bit mouse over the top.
Yes.
Yes, and you have there now there. I think there is a tour, or maybe it's on the drop down. But
Yeah, but I want to just to explain this one. That is the same
yeah,
tour. So
it's good.
perhaps
So
that's
I
why I
would
wanted to talk about the compute there because
yeah,
you use this
the
there.
compute is basically a execution unit where the code will be executed, right? So
Okay, that's
this
great.
notebook needs to be executed somewhere. And
Yes.
for this, we need a virtual machine hosted in Azure that will do the work. And on the compute, we can create an instance or a cluster. I really like to create a cluster because it's a lot better. Instance will not go down, but the cluster, it will completely go down or it will not be used as soon as you stop using it with a
Yes.
few minutes that you can configure.
Yeah.
And you can scale like a set of one VM or several VMs that will do the work for you. So it's super, super
So
useful this case.
that's great. That's great. So on your first steps, if you're not familiar on Azure ML, you can create compute instances on CPU, GPU. That's really
Mhm.
fast. You just grab what kind of set do you want there, and it will be it will be working for you somehow.
Careful with what you
When
pick.
we no, you can train this one. I was creating this 2 years ago on my
Yes.
MVP tenant that is
Mhm.
was provided from by Microsoft, and I forgot this meta 72B there for 2 weeks.
Oh,
And it
ouch.
was 2000 I think, or 3000 euros. They were
Oh my God.
gone somehow because I was presenting, that was a demo, and then I forgot to delete this one. That's just really great, Jose. You said this one. If you
Yes.
create this, be aware you stop it or somehow kill it. So delete it after this if you do not use it. On a cluster, of course, if you are doing Azure Machine Learning, for example, AutoML, you can create a cluster on a run. So you're creating experiment, run experiment. It's create your nodes, one for whatever you want. It's depending on the setup. And
Mhm.
if this experiment is done, the cluster will be stopped automatically. That is
Exactly.
the idea of what you said. What I like here, of course, is
Yes.
to not only create a cluster, but running them in an automated way. So Microsoft also cares about your costs somehow.
I like this very much because when you do also when you do a notebook, usually you
Yeah.
consume only one node of a processing unit.
Sure.
But when you do this, what you mentioned, the one
hmm
just below automated ML, I think this is
hmm
super powerful because
Yes.
this is automatic ML is
Yes.
AI doing machine learning, and that's
hmm
super super powerful.
Okay. We're talking about this one in a moment, but there's also one side what I liked the Microsoft proposed us if we do not create some compute instances for running some infrastructure there for Azure Machine Learning, you can go serverless somehow. As I was starting here years ago, it was only one opinion or one option: compute cluster or compute instances. That's it. So you have to care about this one on your own. If you just switch to this one, it's serverless, so you do not need to configure this one on your own, and it's running only for connected to your workspace, running your client, create the environment, whatever. And then you see what we see here. You need some data. So where is the data coming from? Of course, from your side. So you have to train the model on your data and so on. And of course, doing this one. When we creating the model somehow, Jose, um, how can we use it? So I want two endpoints somehow.
Yep. When you create a model,
Yes.
when using one of the different authoring methods, so you can create a model using a notebook, automated ML, or designer, or even prompt
Yes.
flow. Even
Prompt
prompt
flow.
flow is more
Yeah.
for testing them.
Mhm.
You can first connect it to train,
Mhm.
connect the data, which can connect to anything, almost anything you have in Azure,
Mhm.
right? It can
Yep.
be just JSON files, which is easy, or you can connect it to Fabric or anything. And
Mhm.
then on the model,
Mhm.
if you can close that.
I wanted
Oh,
just to show what is prompt flow,
okay.
because you will see
Yes.
also on Azure Foundry there's also a
All
prompt
right.
flow. But
Yes.
its cloning is
Yep.
should not take that long. Sorry for this one.
No
Perhaps
worries. So
yes.
on the model, once you have a
Yeah.
model,
Mhm.
you can provide it. You
Mhm.
can add it to a pipeline and expose this pipeline through an endpoint, so it can be used
Mhm.
by other Azure service, like one more service,
Mhm.
which this can be also authenticated, completely secure. So you can
Mhm.
put your models into production.
Mhm.
Usually, model is anything that you can do with traditional machine learning, which are
Mhm.
regression models. You can do there, for example, a prediction model, which is one of the most use case, a classification model, or
Mhm.
other kind of more advanced model like time series prediction, which is a bit more complex. But you can do
Mhm.
all these inside and more inside Azure Machine Learning and expose these models. So
Mhm.
not everything needs to be um, generative AI, right? So there's use case for this, and Microsoft knows that well. And this is
L-
where this
Yeah.
Azure Machine Learning comes in.
Let's do not talk perhaps about GenAI if we are introduce Azure Machine Learning,
Yes,
because for GenAI you need a really big model with a lot of
exactly.
knowledge. And if it
Yes.
compares on my data, what I'm putting inside, I do not spend millions of dollars somehow to run
Yes.
this kind of power. That is a perfect transition, I think, because we have spent a lot of time right now. We wanted only 8 minutes to talk about this one, but
Hmm.
that is a great transition to talk about this. To go to Yimi to talk about, okay, if we are going on Azure and we want somehow to get some models there, how fast would it be, and what is the difference to the earlier stage what we talked with Jose right now compared to the Azure AI services what Microsoft provides to us?
Perfect. Thanks, Alex. Thanks, Jose. Should I take over the stage
Yes,
now?
please, the stage is yours.
Perfect. Perfect. So, good afternoon, everyone. I'm Emi. I am an AI solution engineer from Microsoft. I'm super happy to be here today because we are all AI fans. And thanks for the invitation, Alex and Jose, so that I can be here today. So what I want to talk about today is basically guide you through the key aspects of fine-tuning language models on Azure with both AI Foundry and of course with possible open source frameworks. We will start with an introduction to the concept. Then we'll have a very detailed look at the fine-tuning process using Azure AI Foundry, Azure Machine Learning, etc. Finally, we'll also summarize our findings and insights, ensure that everyone leaves today with a very comprehensive understanding of the topic. So first, let me start with the groundwork of understanding fine-tuning, which is essential for us to grasp the fundamental concepts for how to do the fine-tuning for language models. Yes. So first, let me discuss with you the nature of large language models. These models are actually pre-trained models on vast public data sets. In the latest research I've read, around 70-80% of the public internet data set is used to do this pre-training. And this gives us the possibility to tackle really a wide range of problems in different domains. So everyone knows how powerful AI it is today. We can use it to really solve a lot of problems and tasks. However, to be really 100% effective, we can even customize these models using different techniques. And this customization is very important for us because we can tailor the responses of the language model to very specific use cases so that we can have this 100% customized and high quality of replies, of image generated, etc. Every kind of format of responses we can have, we can make it customized. Yes. So let me show you this diagram, which shows us a very simple overview of how a large language model processes text. First, you give the language model a sentence or a phrase, for example, this quick brown, into the model. And the model starts by first converting your words into this numerical representation called embeddings, which help the model understand the meaning of the text that you just given to the language model. And then these embeddings pass through several layers inside of the model, which is a neural network. Each layer helps the model capture more complex patterns of your input text and also the relationship in the text, like the synthetic and semantic context before and after your input text. So in this illustration, you can see that layer 1, 2, 3, and 4, and real models even have more and more layers, like more than 1,000 layers, etc. So finally, after the text has gone through all of the layers, the language model will give you the information and produces the model's output. And this would be basically a prediction of the next word in the sentence when it is generating a response for you. And in summary, that is how language model takes your text, transform it into numbers, process it through multiple layers, and then give you a very intelligent output. And now I want to show you the different ways you can leverage to customize a generative AI model. First, what we can do as the simplest way is to do prompt engineering. Everyone knows that it's basically just customize your prompt and pipeline to get the model behave in a certain way without changing the model's parameters. The second way would be this RAG, which is called retrieval augmented generation. Here you can really combine a language model with your enterprise data or your customized database. This will give the model the ability to really pull in relevant information to provide more accurate answers. What we also have, and what will be the focus of today, it is fine-tuning, where you can adapt a pre-trained Gen AI model, a language model, to your specific data sets or domains. This will give the model the ability to really perform even better and more customized for your unique tasks than the retrieval augmented generation. And of course, the highest level of doing customization is to do the pre-training completely yourself. This is really a very resource-intensive option. Here, you basically train a language model from scratch. So here, from left to right, we can see with each step, we increase in accuracy, complexity, and also it requires more computing power. Yes. So what is fine-tuning exactly? Fine-tuning is a very important technique in machine learning, which allows us to adapt pre-trained models to very specific tasks or use cases. With training on very small and targeted data sets, we can significantly improve the model's performance for our specific applications. And this is what we want to have a deeper dive today with Azure and all of the services, computing powers we have on Azure. And before we start with all of the fine-tuning scenarios and techniques, I still want to give you a heads up on what is really the right place to place fine-tuning. On the left side, we can see that use cases that need a lot of external knowledge, like Q&As, like customer support. For this kind of use cases, we typically recommend to use this retrieval augment generation because it can already let the model pull in the new information this model gonna need for giving a customized answer. And at the bottom right, we have use cases that require a lot of adaptation to your very specific style or behavior, not only on the knowledge level, but also like the semantic or the textual behavior of the model. For example, a summarization in a very specific tone. And what I always like, for example, here is to, for example, have a model that answers in different Swiss German dialects. And this is a use case where we can use fine-tuning because we are basically teaching the model to behave in a certain way using our own training data. In the upper right corner, we also have use cases where we need both of the techniques. So we need both the external knowledge, but at the same time, also lots of model adaptation. For example, this customer support automation is a hybrid approach where we can have both fine-tuning and reg. Now, let's have a deeper look into the fine-tuning scenarios. Fine-tuning is really great for domain-specific applications. If you have very narrow task requirements, for example, generating a joke for children, or I don't know, write a book in the tone of Einstein, this kind of tasks, you need your model to do something very specific, to have this very specific tone, accent, sentiment for a certain type of tasks. Then this fine-tuning gives you this exact capability of doing this. Fine-tuning also helps you when you want to improve efficiency on smaller data sets. So if you don't have a lot of data, but you still have want to have 80% of the performance of a ideal scenario, you can still get very high accuracy by starting from a pre-trained model and then just fine-tune it with the small data set you have. So not only we recommend that you should at least have 1,000 very good quality of training data records with both input and output data set, so you can achieve this 80% of ideal performance. Finally, fine-tuning is also very important for low resource languages or very specialized dialects, like what I mentioned before with the Swiss German. So yes, basically we have different scenarios for fine-tuning. And it is also super important for us to notice where fine-tuning is not suitable. For example, you don't want to start with fine-tuning if there is no clear use case for fine-tuning, or if you identify cost as your primary motivator, because fine-tuning might reduce cost for certain use cases by shortening prompts or allowing you to use a smaller model, but there is a higher upfront cost for training, and you have to pay for hosting your fine-tuned models or adapter, etc., with a compute either provided by yourself or on Azure. Finally, if you want to add out-of-domain knowledge to the model, you should start with retrieval augmented generation first, start with reg, and then you can see with this more cheaper, more adaptable option, if you can already achieve a very desirable performance. If so, you also don't have to do this fine-tuning. That is something that I really want to give you today before you decide to do a fine-tuning. Now, I also have some fine-tuning numbers on use cases where it performs really better than a pure reg. So yes, Microsoft recently published a case study looking at the different performance or impact of this retrieval augment generation and also fine-tuning on improving the accuracy and also the conciseness of an agricultural chatbot. We can see that both with reg and fine-tuning, we have great improvements, but with reg and fine-tuning combined together, we basically have the best performance across all of the combined methods options. And now I want to discuss with you how to do fine-tuning, what are the methodologies, what are the techniques, and what we can have as best practices to help us really do a fine-tuning without using way too much compute powers. So first, let's look at how a language model or an LLM is generally getting pre-trained. So first, we need a lot of text data to train the model, which is called this input training data. This includes information from many sources like websites, books, public code repositories, etc. And then the model goes through this pre-training process, which uses this neural network called transformer. During this pre-training process, the model learns the patterns from the training data and tries to find out how words fit together by looking at billions of examples at the same time. And after this pre-training, we have a special step called RLHF, reinforcement learning from human feedback. We also have labeling and tuning. And here is a post-training step where humans can step in, help the model learn by giving them feedbacks and more labels. And finally, we also have fine-tuning on domain-specific data. This means the model can be further trained on very specific and small task domains, such as answering, medical questions or writing code or summarizing emails, etc. So yes, if we look at the table, we can basically see the different types of data we use to train a model like GPT-3. Of course, we have a lot of open source and other tools that leverages this language models. We have different data sets that we can curate for the training process. And it is really most decisive for the model's performance to have good quality of training data and at the same time, good quality of human feedback and further instructions in the post-training process. Now, let's look at 3 main ways to fine-tune an existing large language model. The first approach is called self-supervised learning. This is a lot like how base models are originally trained. So the model reads lots of text and tries to predict the text word in a sentence. The key difference here is that you can basically choose your own text or training data. Like you can use your personal blogs or, use your WhatsApp chat histories if you would like to train the model to behave in the way that you would like to have. For example, I can basically digitally clone Emi myself to talk in the way, behave in the way, just like I would do in my daily life. The second approach is supervised learning, and this is probably the most common fine-tuning method. Here, you can really create a data set of questions and answers or this input-output pairs. And this can help the model learn how to answer the questions directly instead of just predicting the next word in a sentence. So that is also the reason why people very often use something called prompt templates to format this question-answer pairs in a way that is super easy for the model to adjust. Then the third approach is this reinforcement learning, or in short, this RL, which is a more advanced method. It is used by a lot of OpenAI models, for example, this Instruct GPT model. And it's basically a process of 3 steps. So first, you do supervised fine-tuning, like what we just talked about for the first approach. And then what you will do is to train a reward model. With the reward model, you can basically imagine like I have a mechanism to tell the model if the answer you generated is good or bad. So here we can have some human scores or some other labelings to train this reward model. And with this model, I can give feedback automatically to the answers generated by the model. So yes, in summary, that is basically the three ways that you can use to fine-tune a language model to give them more context, to teach it in a way that you would like it to behave, and also use human feedback and rewards to guide this training or reinforcement learning process. Okay, what we have as the biggest memory, the bottleneck is basically the memory when fine-tuning large language models. Why is it the case? Because regular fine-tuning can easily go over a single GPU's memory limit. Neural networks are designed in a way that it really needs a lot of memory during the training. So the main things that can affect a memory usage here is, for example, the total amount of the parameters in the model, and also how many of these parameters do you want to update during the training. And we also have this numerical format used, like whether you use this 16-bit or 32 bits of numbers to train the model. For example, if you have a 7 billion parameter model, the calculation would show us you would need, without any optimization techniques, already 98 gigabyte of memory to fully fine-tune it. But most of the GPUs only have 24 gigabyte. So the reality is it's very difficult to train or fine-tune these very big language models. Another thing that we have to know is the difference between trainable and frozen parameters. Trainable means the parameters can get updated during the training, which uses more memory. And on the other side, these frozen parameters means the parameters stay at the same and don't use as much memory as these trainable parameters. So the conclusion would be the more trainable parameters you have, the more memory you would need, because you have to allocate memory to save these trainable parameters. The memory is basically consumed by this following types of parameters. First, this model's original weight, and second, the gradients, which are needed to update these weights. And the third one would be this optimizer states, which help the model to learn better during the training process. Finally, it's also important to have this activation. For example, this Adam activator, which is basically some temporary values that is saved during the training process. So yes, in summary, fine-tuning models really need a lot of memory, and it depends on the size of parameters you want to train, right? And that leads us to some memory efficient techniques. So here I want to show you two different techniques that I use very frequently in my daily job. Let's start with this parameter efficient fine-tuning. This is basically a memory reduction technique by reducing the number of trainable parameters. It works in this way. Basically, you have a small set of parameters, and each time only this small set of parameters will be updated. So you don't have to allocate memory for all of your trainable parameters at one time. And another very useful technique is basically this quantization. Quantization is basically you convert a model from this very high bit format to low bit format. In this case, you will have this floating point from 32 to 16, or even 8 or 4, depending on the precision and performance trade-off, or the computing power consumption trade-off you'd like to have. In this case, you don't train all of the parameters, but only the most important hyperparameters, and you will have like a adapter at the end that can just customize a small domain of behavior from the bigger language model. So here I have some examples from both quantization and this parameter efficient fine-tuning. What I think is most useful is first this low rank adaptation, which is basically reduce the trainable parameters, and you will have less computation power needed to, and also memory needed to train the model. And the second one is even more efficient than this low rank adaptation, which is this quantized low rank adaptation. It combines both this low rank adaptation with this 4-bit quantization. So in this case, you even have a smaller LoRa adapter trained, but at the same time, you still have very high precision because you only train for a very small domain of the behavior of the language model. Yes. Now let's talk about how to choose the right training parameters when fine-tuning a language model. I have here the most important parameters, and later we'll also see in a code snippet on how these parameters are set. So first we have this batch size. This is basically how many training examples you use in each training step. A bigger batch size makes the training process much faster, but it also uses much more memory. So you really here have to find your own balance of speed and accuracy. The second parameter is this learning rate multiplier. This controls how quickly your model learns new stuff. So if the value is more than 1, the model learns faster, but it might skip over the best solutions. It is again something like the example that I always love is if you watch a YouTube video, you can turn the speed to 2x or 3x if you think you can adjust. You can really digest the new stuff very quickly, but at the same time, you are also risking that you are losing some details. And that is exactly what this learning rate multiplier is doing. Then we have this epochs. One epoch is basically one complete pass through all of your training data. So if you train for a lot of epochs, it means basically your training data will go through the whole training pipeline a lot of times. And basically, in the practice, we see if you train for too few epochs, your model won't learn enough because it is underfitting. But if you train for too many epochs, your model might memorize the data. And in this case, we'll have something in another extreme, which is called overfitting. And the last parameter is seed. The seed is basically a randomization added on in the training process. It sets the starting point for random numbers in your training run. If you use the same seed, you will always get the same results each time. So this parameter helps us if you want to repeat your experiments and compare different results. And that are the most important parameters for fine-tuning a model. And what I will also want to introduce is this continual fine-tuning, which is essential for maintaining the relevance and also accuracy of your model. So every time you update a fine-tuned model with new data, you can ensure it adapts to the changing conditions, and it also improves over time. And that is what we call with this model maintaining. It is super important to keep most of our parameters that we just discussed before consistent, so that we can basically retain the model's learning behavior. And we can also, in this way, even optimize the training process. The only exception here is this learning rate. We can always adapt the learning rate depending on how much or how quickly we want the model to learn the new stuff. Lower learning rate could be beneficial because it allows for more gradual adjustments, but it can also prevent some optimal solutions. So it's really a trade-off at the end for what you would like to have for a desirable performance, and at the same time with certain free space for the model to be innovative. Yes, now I want to introduce you a new method for this preference fine-tuning, which is called direct preference optimization. This approach can be applied to both base models and that models that already undergone a fine-tuning. So with this DPO, we can basically enhance the accuracy of our models with some experimentations. For example, if you would have here a prompt like a customer messages, "I'm having trouble with my internet connection. Can you help me fix it?" You will have two different responses, like what we'll also see here, and you will give the user the possibility to choose directly between different options what is preferred by the human. Yes. What is important if we want to consider DPO, the first one is modality. I'm having a look at the time. We don't have so much time anymore, so I'll skip this part a little bit. So basically have to consider modality and also model availability, new parameters or hyper parameters for DPO, and at the first position also possible workflows or the stacking methods to use DPO to combine it with supervised fine-tuning. Okay, this is also very technical for reinforcement fine-tuning. This is basically a new way to fine-tune models that is better at teaching them how to reason, though it can sometimes take more time. For time reasons, I would also skip this slide. And we can now have a very, very short comparison between DPO and RLHF, reinforcement learning from human feedback. This RLHF is basically a process like we start with preference data from human, and then we have this very specific reward model that is trained to label how good different responses are. And then the model uses reinforcement learning to get better by basically sampling and also getting feedback from the reward model. On the other side, we have DPO, direct preference optimization, where we can basically directly use preference data from real humans. So instead of building a separate reward model or running a reinforcement learning loop, DPO directly adjusts the model based on what answers are preferred by the real human. This makes DPO really much faster, simpler, and less expensive. For fine-tuning, we have some good practices. What I would say here is first, we have to decide on a very, very specific use case, because otherwise we can use rec or prompt engineering to solve our problems. And second, we also need a baseline, which we can use prompt engineering or rec to set up. And the third step would be problem definition. What is exactly the task that you would like to improve with a language model. The most important thing is always we have like a large amount of high quality training data. And if your data is bad, your model is also bad. So you always see garbage in, garbage out. So this is really matters a lot, the quality of your data. The final step is basically evaluation, because after your fine tuning, you have to check your model's performance. And this is the place where you can use a lot of benchmarks to test your model against the foundation models or the base models from your fine-tuned model to see how much better your model is getting. Some final thoughts would be first, start small. Begin with a very clear business case and a very well-defined task. And then I would really recommend use this super efficient methods like quantized low ranker adaptation, QLoRa, to save resources while still getting a pretty good result. The second one is to focus on data quality, because only high quality, diverse, and well-formatted training examples can let the model not being too much constrained, but at the same time still very specific and precise in giving the answer. The third thing is evaluation is really important, because the technical numbers, it can mean everything, right? We can also manipulate the benchmark to let our fine-tuned model outperform all of the other foundation models. But what really important is to check the real performance with some evaluation tools, for example, on Azure, or some benchmarks with the base models or the other foundation models, so that you can be really sure about the improvement of your fine-tuning process. And finally, it's always good to combine fine-tuning with retrieval augmented generation with rec, because as we shown before, with this combination, you can achieve the ultimate best result. Considering the time, I will directly jump into the next chapter, and we'll save some Q&A time at the end. So now I want to show you how fine-tuning on Azure basically works. So on Azure, you can choose a model to fine-tune directly from this model catalog. In Azure, we have not only this OpenAI models that have cooperation with Microsoft, but all of this most popular foundation models, the small language models like Phi, and even some fine-tuned models from the other people that they have published for you to directly reuse. We also have a lot of machine learning models or neural networks that you can take out of the box and train further on. So you can save a lot of training cost for this pre-training stage. What you have to consider is, of course, the cost, how much cost you would like to invest in this fine-tuning process, and also this customizability. You have to think about how you can change the model, because sometimes the models can be super flexible, especially the super large models. But considering the performance or the specific task, sometimes it's even smarter to use a smaller model, because the smaller model is already smart enough for our simple domain tasks. What we also have to consider is convenience, like how easy it is to actually do the fine-tuning. Do you have to write a lot of custom code, where we can see later on Azure that we can do basically the fine-tuning with some clicks in the AI Foundry if you do not require a lot of training data and a lot of learning steps. Finally, we also have safety. This is also a topic that's super important. How can we guardrail to have safety measures to prevent us from any harm from the other sides of the application or from your model usage. Now I want to show you the different Azure fine-tuning options. First, we have Azure OpenAI, which is a fully managed service. You don't have to worry about any infrastructures. It's just like using a model directly from a web interface, right? You can have the option to use all of these OpenAI models, and you can select your own regions where you want to have the fine-tuning and training process done. And at the end, when you consume the model, you basically only pay for the token for the fine-tuning and inferences, and by the hour for hosting your fine-tuned model. The second type of fine-tuning option is this Foundry serverless fine-tuning, which is also a fully managed, but supports different models like this other popular language models, foundation models, and even some small language models. And here you still don't need to bring your own GPU. You only pay for the usage of your GPU and for hosting your fine-tuned models during the inference time. The third option would be this MAP, which is basically Foundry managed fine-tuning. Here you can bring your own GPU capacity for both the fine-tuning and also for the inference. And here it works for even more models and in all of the regions, because we don't have these constraints on which data center has at this time point the GPU that you would need. And finally, we also have Azure Machine Learning, which is like super flexible and highly customizable if you're a techie, if you're an AI geek, and you want to do everything yourself. Here you also have the possibility to bring your own GPU, and you can fine-tune basically any model or even the custom ones. As you can see from left to right, these options are getting more flexible, but also more complex. So you, as a user, have to manage actively more configurations and more compute resources. Okay, so here I also have some Azure OpenAI fine-tuning options. Considering the time, I'm also skipping this one because I still want to show you the demos at the end. Okay, now let's talk about this data preparation or this synthetic data generation super quickly. What is this synthetic data generation? It is a process that allows us to basically create artificial data sets that mimic real-world data. This is extremely useful if you do not have so many real data, or it's difficult to collect the data from your end users. And we have a lot of methods or scenarios where we can use this synthetic data generation. So for example, we have this augmenting data sets for low resource languages, or simulating this rare scenarios for task-specific tuning, etc. So we really have a lot of scenarios where synthetic data set is not necessarily a bad thing, because people always say, you know, it's not real. You can get a wrong performance with this low quality of fine-tuned of synthetically generated data. But actually now we have so many different methods for us to directly not only generate the synthetic data, but also filter them, post-process them to ensure the quality of the synthetic data is really high. Especially if you already have a small set from your user, which is like real data, then you can let the language models or some other machine learning models learn the pattern from your real data and apply this pattern to generate more synthetic data sets to fine-tune your model. We still have 5 minutes, and now let me just jump into the demo part. So what I want to show you today is first fine-tuning with some open source framework. Here I have this example with Onslaught, which is an open source library designed to make fine-tuning large language model much faster and also easier, most importantly, more memory efficient. So here we already have built-in support for all of the techniques we discussed before. For example, the slow ranker, adaptation, and quantization of LoRa, etc. And we also have a lot of small models already available, so that you only have to select a model and then you can already start training with very limited computing power. Here I have example with me on a synthetic data set that I generated for one of my customers, where you can see I have basically over 1 million data set generated for this specific task domain. And I use some machine learning algorithms to filter out the bad quality, the bad ones in the generated data set. And I published this data set like 2 weeks ago, and I can see already some people are benefiting from my data set. And let me show you a little bit of code on how this is done. We have different steps to do this fine-tuning task with this open source framework Onslaught. So basically, at the beginning, you have to set up everything. You have to load the base model, and then you can configure your LoRa adaptators. So here you can see all of these parameters that I discussed before. And depending on the trade-off you'd like to have, you can set different values, like how deep or intensive you would like your model to be trained. Here you can also use training data set. If you don't have any training data set, you can also have a look on Hugging Face. If there are already some released data sets that you can directly reuse. And then for the trainer part, you can really adjust the parameters to the level that you would like to have. Here again, all of these parameters that we discussed before. And after these 5 steps, you can basically start the training already. Here I have some examples with this pre and post training comparison for a small language model, Llama, that I trained for generating jokes for small children, where we can see it's really performing very different now. And if I can directly show the code, so basically I can just go to my machine learning notebooks, and here I have a demo script for use Llama to do the training. It is exactly like the steps that I discussed before. The most important thing is here setting these trainer parameters. I here also add some comments on what is the recommendation for each parameter. You can really decide on if you want to leverage the whole GPU capability or only use part of it. And most importantly is you connect your Azure Machine Learning to a storage account that is large enough, because if you really want to do intensive training, you have to somewhere store all of your parameters, trainable parameters, on a storage option, which I really recommend to use this large space. I would say at least 50 gigabyte for training 8 billion language models. Let me go back to my presentation. Yes, I have to start again. Swap. Now, yes. Now, the last thing I want to show only for 1 minute is to fine-tune with Azure OpenAI Foundry. So here you can see directly how easy it is to directly combine your training data, validation data, and then start training. Yes. And after the training, you can directly deploy your model on AI Foundry, even the fine-tuned ones. It's only some clicks on AI Foundry. And with this, I will end my presentation now. A short summary or reflection for us on what we have learned today. Fine-tuning techniques, what is important, best practices for fine-tuning, how Azure OpenAI, Azure Machine Learning can help you, Azure AI Foundry can help you to do the fine-tuning, and finally, how to do this synthetic data generation. Now, thanks for listening. I'm open to questions and discussions.
That's
Hey,
nice. Thank you very much.
that was really good.
So first of all, some feedback directly. Love this stream. There are some guys, they are looking at this one. We have some questions, of course. And the one is, if you want to start, what is the difference between fine-tuning CNN architecture and fine-tuning an LLM on transformers? And also thank you for doing this one from Jose. So another Jose, Jose Silva.
Yeah, so basically this transformer architecture is a much more advanced version of this neural networks. It's two, yeah, I would say different level of depths, like how many layers you would have in between. So here the most or the biggest difference is basically on how intensive you have to train the model. Especially with language model, we often have the problem that it is closed source and you don't have access to all of these trainable parameters, and you can only do it either indirectly via Azure AI Foundry. For example, you can do a fine-tuning for even GPT-4o currently, which is a closed source model, or you have to apply for access for this model directly with the model providers.
And we stream to also YouTube directly and also to LinkedIn. There's another question from LinkedIn right now. During the grant process, how do we ensure that the model follows the company policies? Consultancy life.
This is a very tricky one.
Yes.
And by the way, I have to say that the person asking that is not just one more. It's Stephen Simon, which is one of the most active persons in Azure and machine learning and AI around. So, hi, Stephen. Good to see you here.
And let's talk about during the grant process, how to do the model follows the company policies. Of course, if you train your model somehow, we talked about it on Azure Machine Learning. The idea earlier, before LLMs and so on, then the model will be generated or trained on the data you provide. So if your company policy is to get questions or answers to questions only depending on one data, what is fine on compliant on your company, then you have to provide the data somehow. Was also Yimi was mentioned on Azure AI. Somehow you get your LLM from Microsoft, you get your first base model, and then you fine tune this one also on data. So earlier we do not have some LLMs. Today we're starting with LLMs because they knew a lot of stuff right now, and then you just fine tune them for specific tasks somehow. For this specific task, the data you put in should be compliant from your company. So follow the governance and compliance processes. If it's working there, I think that the most important part is to get this data. So Yime was showing earlier, she was creating some data, some data for specific task. So how to be sure that this data is do not have something inside that is not allowed by the company policy. So you have to clean up, I think, if you're going this way. So if you're afraid of, you got your training set, you put it in, that's fine-tuned, that's it. If you then think you will point to something that is not compliant to your company, then you need to clear up first before you're doing the fine-tuning. Because if your network was trained and it's learned not compliant data, you have no chance to get it outside. It's already there. So I think the first point is to start at the beginning and follow the whole compliance processes from there. Oh, that's nice. Mohammed was asking which editor is best for machine learning models training. Oh,
Alex,
it
I
depends.
would,
It depends.
Totally.
Alex, can you hear me?
Yeah. Yeah, sure.
I
Please
would
go on.
add to the question from Simon
Yeah.
as well that it can be compliance, but it can be as well guardrails and everything regarding a specific policy to address in that company, right? So it's multidimensional, like for example, professional standards, risk management, regulatory. This is compliance, right? So it's well, one thing is how much can we train a base model, and then this model can be trained in another, and also this model can be used to verify the training data for the other model as well to verify that. And also one thing that really works really well is to have a secondary agent that the only input is to, okay, review the input that goes into this model, right? And check if there is any violation of
Yeah.
this
Yeah.
standard or anything that could trigger a violation.
Yeah.
And do that as well in the output. Of course, this thing will cost a lot of money more because
Yeah.
it's token usage and it's a model that probably needs to be deployed.
Yeah.
But
Got it.
it's the only way to be safe from anything that could violate these in case that you put a model with public access like a public agent chat.
Yeah, he was asking about ground process. So on the
Yes.
ground process, you provide information to your model
Hmm.
somehow.
Yeah,
So that's
the
why I
grounding.
was based on uh, show the model only the data you ensure the company policy. Because
Yep.
if you talk about ground process, if you remember the Copilot somehow, you get your query, then you ground it with all information you get in your tenant, your emails, so on the Microsoft Graph, and then you're going to LLM. So if you're putting bad data in this ground process and throw this one to LLM, I don't think you have any chance to go to get it then away from this one. But
Absolutely
back to
agree.
the Mohammed, please. What is the best editor? For myself, it depends on your knowledge somehow. Where do you starting then? Because there's also machine learning studio. You can do a lot of stuff. What Yime was saying earlier on Azure AI. Can start on Azure machine learning portal. So there's a lot of things you can then figure out somehow. So it's not only one is the best and the others are not working or something like this. I don't
Here,
think so.
I would like to add as well that for machine learning, you have for Visual Studio and Visual Studio Code, you have machine learning AML. Sorry,
Yes.
aside from the website, you have
Yes.
ML.net, which is
Mm-hmm.
integrated in Visual Studio,
Mm-hmm.
the big one, and there is a plugin for Visual Studio Code.
Yeah. You're right. That's
and,
nice.
and this and
Yeah.
this works fantastically well,
Mm-hmm.
and it's integrated in the IDE, so you can basically drag and drop things in the studio. You have also a platform
Mm-hmm.
which is a designer where you can drag and drop in your IDE on Azure Machine Learning, automated machine learning, and you can
Mm-hmm.
execute that in your local computer,
Mm-hmm.
and it goes out quite fast if it's not
Mm-hmm.
too big. And you can also use the resources or the
Mm-hmm.
clusters that you can create in Azure as well.
Okay, nice. So we are somehow 10 minutes over the time for the live stream, and we have some last feedback. Great talk. Thank you all from Jose Silva. Thank you very much. This feedback is for you. So thank you for your time. Appreciate it. It was an awesome deep dive in a few somehow in a very short time. Perhaps we need 2 more hours next time.
There's
you very
always
much
more
for joining.
topics to talk about. Thank you
Yes,
everyone
sure.
for joining
Thank you
and
very
for the
much.
great insights.
Thank you so
Have a
much.
great day.
Thank you.
Bye bye.